Your section 6.1 homework will kind of ease you into this normal distribution stuff with bare bones number crunching before we start attaching it to those pesky words and paragraphs. And we're going to be practicing on StatCrunch, which you see over here. This is a really good normal calculator. I'm kind of excited because, again, I'm accustomed to doing this with tables, and it's really nice to have a built-in calculator / computer that'll do the hard work for us here. So let's make sure we can find this calculator first. When we're in StatCrunch, let me close it for now. We go to, and these instructions are given in your lecture outline, Stat Calculators Normal. Well, that makes sense. And this is the default. The default is standard, which means, again, 0, a mean of 0 in the middle, and a standard deviation of 1. Now, I've decided that for the purposes of our class, we should always click this between. Otherwise, it's going to start to feel like there are 2 or 3 kinds of problems, but we can really treat them all using this one single default. So what between means is that, again, the area, shaded red here, is always over an interval. It's never only over a single point on the number line, but between 2 points on the number line, an interval. So in this case, it's between -1 and +1. So what the display is showing us down here is that the area between z-scores of -1 and +1 is about 68%. And you should remember that number because we've discussed that rule before. Okay. So I want to start with some questions over here. I want to practice the art of drawing them first because when we draw them, it really helps us really see what the minimum and maximum are. Okay. So the first question says, find the area between z equals -2.3 and z equals +0.8. So I'd like to draw that first. This one is pretty simple and self-evident, but let's just get in the habit of this. So between the z-scores of -2.3 and +0.8. So I'm going to go to my standard normal template, and I'm going to mark off a z-score of about -2.3, right about here. Okay. And +0.8, which will be about here-ish. And the question is to calculate the area between them. So we go straight up to the curve. And we are basically looking for this area, which we can shade so we can see what it looks like. So it's very clear when we go to the normal calculator that we're going to be typing in a minimum of -2.3 and a maximum of 0.8. And the calculator will give us the area in between. So the way this works is that there are 3 blanks down here. We're always going to fill in 2 of them. StatCrunch will find the other one. So whichever one they're asking for, we're going to leave it blank. This says find the area. Okay, so the area, that's this box here. We're going to leave that blank. As soon as we blank it out, this picture disappears, and that's why it's so important for us to do the drawing beforehand. Okay, now we're going to be able to fill in the minimum and maximum. So in this problem, the minimum z-score is -2.3, and tab over to the maximum, which is +0.8, and then click Compute. And StatCrunch tells us that about 77.74% of the values lie between those z-scores. It's shaded it in red for us, and hopefully, if we've done things right, that picture should look like ours. Oh, good. Whew. We're doing well. All right, let's try the next one. Find the area to the right of z equals 1.23. This one doesn't look like a between problem. So let's draw it and see what happens. Let's clear this. Oh, I forgot what the number was again. Okay, I printed this out for myself, like I should have done in the first place. All right, find the area to the right of z equals 1.23. Well, let's identify that z-score first. Z equals 1.23, more or less here. Darn it. Okay, 1.23. And I'll draw that vertical cutoff. And that's the only z-score that it gave me this time. Only one z-score. And then it said find the area to the right of that. So I'm going to shade that. So if we compare that to the values that we're supposed to fill in, StatCrunch is going to ask us for a minimum and a maximum. What are we going to do? This one doesn't have a maximum. It's only got a minimum of 1.23. Because this maximum basically goes off to infinity, doesn't it? That's where Buzz Lightyear is, somewhere out there. We can't type in infinity, so what we're going to do instead is just type in some off-the-charts large number, like 99. In fact, I think even probably 4 or 5 would work, but let's just go overboard and say that infinity will be represented by like 99. So, we are going to clear the area because that's what they're asking us for. And then we're going to type in our minimum of 1.23 and our maximum of infinity, which we're representing with a really big number like 99. Compute. Well, there's the right tail. That agrees with the picture we drew. And it tells us that the percentage is 10.93%. I think by default, these percentages are rounded to 4 decimal digits. 0.1093. That would convert to 10.93%. Question 3, find the area to the left of z equals negative 0.14. Okay, z equals negative 0.14, negative 0.14. So that's pretty close to 0, right about hereabouts. And draw the vertical cutoff there. Boy, that's pretty sloppy. Okay. And we want the area to the left of that. So we're going to shade that first so we can look at it. And remember, we always need 2 values, a minimum and a maximum. So when we draw the picture, we can see that our negative 0.14 is really the maximum. It's the rightmost point on this interval. And the minimum, I hope you can see again that that's, this time, negative infinity. Okay? And so we'll obviously plug that in with something like negative 99. So clear the area. Type in our minimum of negative infinity, negative 99. Maximum, negative 0.14. Compute. The picture agrees with ours, and the area is 44.43%. Question 4 looks a little bit different. Where is it here? Okay. So this one says find z sub 0.04. So that is the notation for the z-score with a percentile of 0.04. It cuts off, it's the boundary of the lowest 4%. I've summarized that for you in your lecture outline here. The notation, we use the notation z with a subscript of k to indicate the z-score at the k percentile. And of course, this k is written in decimal format. So the way it's written here is 0.04. We all know that that's really the same as 4%. That's 0.04 as a decimal. So how would we draw that? Boy, things are getting tricky here. Okay. We want the z-score that cuts off the lowest 4%, the bottom 4% on this distribution. Where would we find the 4% of the smallest numbers on the curve? Where are the small numbers again? Are they to the left, the right, the top, or the bottom? I can hear you all saying left. Okay, good. Small numbers are to the left, right? I mean, left, yes? So what would the lowest 4% of the curve look like? We want to find only like 4% of the area at the lowest end of the curve. We're looking for a small left tail. And what is that z-score? I don't know. We need to find it this time. So all we do know is that this area is 4%, 0.04. So when we go to StatCrunch, we need to type in 2 of these numbers, and it'll tell us the third one. So let's think about what we know and what we don't know here. We need to know the minimum, the maximum, and the area. Do we know the minimum value, the minimum z-score in this interval? Yes, we've seen this before. This interval goes all the way off to negative infinity. So we can enter in the minimum as negative 99. Do we know the maximum? Do we know the rightmost value? No, that's what they're asking us for. But what we do know is we want the area to be 0.04. And StatCrunch does the magic for us. It tells us the z-score you're looking for is negative 1.75. And by the way, these are always rounded to the 100th place. That's the standard here. And again, I like to double check, make sure that this picture looks like mine. Okay, and then finally, number 5, we're finding the z-score at the boundary of the top 31.68%, or as a decimal, 0.3168. So again, it's best practice to always draw this. Last time we looked at the bottom 4%. This time we're looking at the top 30-something%. So whereabouts is that going to be? That's going to be a right tail this time. We want to carve out about 30% of this area. This is obviously harder to eyeball, but I don't know. I'll just draw something that looks like this, let's just say. And I don't know what that z-score is, but the computer will find it for us. But we want to find the top 31.68%. That'll be the area here in this right tail. So how would we describe this interval, the interval underneath that region, in terms of a minimum and a maximum? Well, it looks like the minimum is the unknown. We're going to let StatCrunch find that for us. But the maximum we know is infinity, 99. So those will be the numbers we type in here. If the maximum is 99, and we want the area to be 0.3168, then what should the minimum be, StatCrunch? Oh, it's 0.4767. I wonder how good my guess was. Oh, I guessed over 1, so my guess was pretty bad. But, well, that's what computers are for. So now we know that the z-score we're looking for is 0.4767.